Welcome to Apply Excellence Tutorials. A quick one, have you subscribed yet to the YouTube channel? If you have not yet subscribed, kindly subscribe and click on the notification bell so that you get notified every time I upload a new video and you never regret. We have a question from Simple Harmonic Motion. A particle moving with harmonic motion has speeds of 4 centimeters per second and 5 centimeters per second at distances 8 centimeters and 6 centimeters respectively from the equilibrium position. Find the period of the motion. Okay, so we've been asked to find the period of the motion, and we know that the period of the motion is given by this formula 2 pi and divided by the angular frequency, omega angular frequency. But if you check, we don't have the angular frequency. This we don't have. But we can use or manipulate what we have been given to calculate the angular frequency. Now, what we've been given the speed and the distances, the displacements. So we can use these displacements and velocities to be able to calculate the angular frequency. How do we do that? We know that the distance is given by amplitude cosine of omega t. This is how the distance is given. So let this be equation 1. So we differentiate this equation for distance with respect to time to find the speed, or to find the equation for speed. So we have speed being equal to change in distance with respect to time, which is basically going to be negative amplitude sine dt. Okay, so this is going to be our speed. Okay, so now what we do with that? So we square both equation 1 and equation 2, and then we sum them up. So when we square equation 1, what we're going to get is this. Okay. And when we square equation 2, we are going to get, so that is negative, is going to be positive. Excuse me. So those are the two equations that we're going to have, and then we sum them up. And when we sum these equations, we're going to have that. Okay. Okay, so I can manipulate equation 2 so it looks in this way. Okay, I divide this through omega so that it suits. So what we're going to have is a squared omega squared, a squared sine. Okay, so that it suits this equation. So we sum them up, and what we're going to have is squared plus this squared over omega squared being equal to a squared. We factor out, and we have this. And what we know is that this here is equal to 1 according to trigonometry. And at the end, we're going to have that. Okay, so that is what we have. And then we can say we let v squared be the subject of the formula, and the equation is going to be v squared being equal to omega squared s squared minus x squared. Okay, so this is the formula now that we're going to use to find omega. So we have 4 centimeters per second speed and distance 8 centimeters. So we are going to place these values in this equation, and also this we are going to have an equation, and also we are going to place 5 centimeters per second and 6 centimeters, and we're going to have a second equation. So the equations are going to look like this. Okay, and then we also divide these equations now, equation 3 and equation 4, because you're going to see that we have two unknowns. We have the angular frequency and the amplitude. We don't know. So we need to find this. So let's divide these two equations. So what we have is 10.5 being equal to 6. So this and that will cancel, and what we're going to have is 25 mega okay, being equal to okay. So we expand this. Okay, we expand this, and this is what we are going to get. So 25 a squared minus 16a squared, we get 9a squared being equal to get 1024. So we divide throughout by 9. Okay, so that is what we get. We get, okay, so I'm going to erase here. Sorry about that. Okay, so what we get is a squared being equal to 113.78, where a is going to be the root of that is 10.7. 10.7. So this is in centimeters. Okay. So that is our amplitude. Now we can place this amplitude in either equation 3 or equation 4, and then we'll be able to get the angular frequency. So our angular frequency is going to be, okay, so we have 49.8. Okay, so we divide throughout. So angular frequency is 0.32143. So we introduce the square roots. and our angular frequency is going to be 0.567. Okay, so we know that angular frequency is measured per second. So this is the angular frequency, and we put in that equation now 0.567. So, and this is per second. So our period now, our time period is basically going to be 11.1 seconds. So this is the time period of the motion. This is how you basically calculate and find such questions. So have you found this video to be helpful? Kindly give it a like, comment, and also don't forget to share and subscribe to the YouTube channel. Thank you so much.